This is pre-calculus video on 1.3, find the nth partial sum. The directions for this problem are find the 14th partial sum of the arithmetic sequence, and it gives you the first 4 terms of this sequence. And then we're just going to add them up. So first we have to list the first 14 terms, and then we'll add them. I've got 4 of them already, and it appears as though to find each new term we are subtracting 6. So after 21, 15, let's do 21 plus 15 plus 9 plus 3, then we're going to subtract 6 to get negative 3. And then negative 9. Okay, and then negative 15, that makes the 7th term. And then negative 21 makes the 8th term. And then negative 27 makes the 9th term. Plus negative 33 makes the 10th term. Negative 39 makes the 11th term. Negative 45 makes the 12th term. Negative 51 makes the 13th term. Negative 57. I just need to count them, make sure I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so I've got 14 terms. I'm going to use the calculator to add them all up. Okay, I got negative 252. Now, going through that process was really merely to prove the point that you don't want to have to go through that process. There's got to be an easier way, and in fact, there is. All right, so here we have 2 different formulas for finding the nth partial sum of an arithmetic sequence. Make sure you have these both in your notes. They both work, and they both arrive at the same answer, but depending upon what you know in a problem, one might be easier than the other. Pause the video, make sure you have these both in your notes. All right, so now I've got the exact same problem, and I'm going to hopefully get the exact same answer, but this time I'm going to plug into this formula. So I want to show you how to use this formula. All right, K stands for the last term, or how many terms we're adding together. So in this problem, K equals 14, okay? We also need to know the first term, which is 21, and we need to know the common difference, which is negative 6. All right, so that's what I need in order to use this formula. I'm going to plug that in. So I've got the sum for the first 14 terms of this sequence that I'm calling u sub n equals, I'm putting k, which is 14, times u sub 1, which is 21, plus k times k minus 1, which is 14 times 13, that's coming from here, k times k minus 1, over 2, times the common difference, which is negative 6. I'm just going to use the order of operations to simplify this. $14 times 21 is $294. 14 times 13 divided by 2 is 91. Oops, 91. (91) times negative 6 is negative 546. And then I'm going to add 294.
Mrs. Jamil, if you're still in the building, please stop by Ms. Burke's office. Mrs. Jamil. Ms. Jamil.
Negative 252. Okay. And by the way, it was the same problem I started with, so I should have gotten the same answer I got here, negative 252. Okay, now just to prove that both formulas give us the same answer, I'm going to do the exact same problem using the other formula. And by the way, the one that you see on the screen now is my favorite of the two. To me, I find this very easy to memorize, and I find it much easier to use, okay? We've got our k over 2. Actually, let me look at this another way. What if I were to rewrite this as k times u sub 1 plus u sub k over 2? Okay? Well, what is two things added together and then okay, technical difficulties, picking up where I left off. The question is, what is two things added together and then dividing by 2? Well, that's the average of two things. So this formula is taking the average, which I've circled in red, of the first term and the last term, and then multiplying it by k, the number of terms there are. Okay, so to me, this just makes a boatload of sense, and it's easier to understand things that make common sense. All right, I am going to plug in what I know to this formula. Okay, so my k is 14, and my first term is 21. Okay. My last term, all right, well, here's where the problem comes. If you don't know the last term, in the 14th term, you might not be able to use this formula. However, I can quickly figure out what the 14th term is, because the formula for the arithmetic sequence is u sub n equals the first term, which is 21. Now let me write the formula. U sub 1 plus n minus 1 times d. All right, well, I know all of these things. The first term is 21. I'm looking for the 14th. So 14 subtract 1 is 13 times the common difference is negative 6. So the 14th term of this sequence, I'm just doing this in my calculator, is negative 57. So very quickly, I found the 14th term. Plus negative 57. All right, so I've got 7 times the sum of 21 minus 57, negative 36. And 7 times negative 36 is negative 252. Which is the same answer I got the previous 2 times, thank God, because if it wasn't, I'd be going real batty. Okay, one more problem, and then we're going to call it quits on this video. Find the sum of all of the multiples of of 4, from 4 to 404. You might want to pause the video, think about this, see if you can give this a shot by yourself. Okay. I am going to go ahead and give this a shot now. I've got the sum. All right, well, how many terms are on this sequence? I'm counting 4, 8, 12, 16, etc. All right, so if I'm counting by 4s, there's going to be 404 divided by 4 terms. So this is going to be from n equals 1 to 101. Okay, of the arithmetic sequence that can be written in the form 4n. That's the explicit formula for this sequence. Okay. I am going to use the formula that I like better, which is k over 2 times use of 1 plus use of k. So I've got 101 divided by 2 times the sum of the first term, which is 4, plus the last term, which is 404. So I've got 101 over 2 times 408. Right? And so 2 can go into 408 204 times. I'm canceling my fractions before I multiply them. Elementary school math. 101 times 204. Calculator. Is 20,604. Alright, I think this concludes section 1.3, all of the videos in section 1.3.